Hello everyone, you are highly welcome to this class, and in this class we are going to continue our study of this topic, inequality, of which we have considered some examples, and today we have this very question to consider, and this is making it the fifth example we are considering on this topic, inequality. So what is given to us on the board? They say the non-negative integers n satisfying the inequality absolute value of 2n minus 1 less than or equal to 3, and we are given this option A, option B, option C, and option what, D. So this is clearly an objective question, so I'm going to solve it formally, then later I will give you shortcuts you can use to arrive at the answer without wasting time, since it's an objective question. So solve it formally. We are going to break this into what, two cases, because we are having absolute value. That's why we are breaking it into two cases. So we have a case for the definition of absolute value if the quantity is positive. We have a case for the definition of absolute value if the quantity is what, negative. Because 2n minus 1 can be negative or what, positive. So we are going to consider the case 1. So we are going to say case 1. So case 1 has to do with if what is inside the absolute value is positive. If 2n minus 1 is greater than 0, if I want to say that something is positive in mathematics, I say that it's greater than what? 0. So if 2n minus 1 is greater than 0, then absolute value of 2n minus 1 less than or equal to 3, which is what we have here, right? So if this quantity is positive, then absolute value will return the same quantity. So we are going to have 2n minus 1 less than or equal to what? 3. So I can move minus 1 to the other side. I have that 2n is less than or equal to 3 plus what? 1. If I move minus 1 to this side, change to positive. So this implies 2n less than or equal to 4, right? So what is the coefficient of n? The coefficient of n is what? 2. We are going to divide both sides by 2. So which implies 2n divided by 2 is less than or equal to 4 divided by what? 2, right? So this simply implies 2 divide 2n, I'm going to have n less than or equal to 2 divide 4, I'm going to have what? 2. I'm going to have that n are all numbers less than or equal to what? 2. This simply equals to, that's numbers starting from 2 down to what? Negative infinity, because we are looking at, they say that n is less than or equal to 2. That's what we arrive at now. N is less than or equal to 2, which means all numbers starting from 2 down to where? Negative infinity. So I'm going to have negative infinity. I'm using open brackets at infinity. That's what you are going to do, because infinity is not a real number. Then comma 2, right? Because we don't have strict inequality, we have less than or equal to. So I'm going to put 2 and close the side of what? 2. Closing it means that 2 is among numbers starting from 2 down to negative infinity. So that's what we got in this case. So we're going to consider case 2. Case 2 is if what is inside the absolute value is negative. We are going to consider the definition. So if 2n minus 1 is negative, less than 0. So if you want to say that something is negative in mathematics, say that it's less than 0. So peradventure what is inside the absolute value is less than 0, that's negative. Then what is the definition for the absolute value? Then we are going to have, then this absolute value of 2n minus 1 less than or equal to 3 will now imply if this quantity is negative, then absolute value of it will be minus of it, because if something is negative, if you do minus of a negative number, you are going to get positive, because absolute value is always positive. So if this thing is negative, then if I take negative of it, then I'm sure I'm getting a positive quantity. So then absolute value of 2n minus 1 will be negative of 2n minus 1, and here we're having less than or equal to what? 3. So we can open this bracket with minus. Minus multiply positive 2n, I have negative 2n. Minus multiply negative 1, I have positive 1. Then I have less than or equal to 3. That's what I have. Then I can move positive 1 to the other side. I have negative 2n left at the left hand side. Then less than or equal to, I have 3. Then if I move positive 1 to the right, I have negative 1. So I'm having 3 minus 1 at the right. So this implies minus 2n is less than or equals to 3 minus 1 will give me what? 2. So what is the coefficient of n? Minus 2. So we can divide both sides by that. So we are going to have minus 2n divided by minus 2. Then because we are dividing both sides of inequality by a negative quantity, inequality reverses. So anytime you are dividing both sides of inequality by a negative quantity, inequality must what? Reverse. If it is a positive quantity, inequality remains the same. So because we are dividing both sides by negative quantity, that's negative 2, the inequality will reverse from less than or equal to greater. It will reverse to greater than or equal to. So we are going to have what? 2 here, because that's what we have at the what? Right hand side. We are going to have 2 divided by what? Negative 2. So negative 2 divide negative 2. What I have at the left will be n greater than or equal to negative 2 divide positive 2. I'm going to have negative 1. So what is the result here? Negative 1 comma greater than or equal to 1. Greater than or equal to minus 1 is starting from minus 1 upwards, right? Upwards towards positive infinity. So I'm going to have close bracket at minus 1 because it's starting at minus 1 towards infinity, that's comma infinity. Then open bracket, you must use open bracket at the side of infinity because infinity is not a real number, right? So let's look at the solution of the solutions we got. So we are having, let me say that here is 2. So sorry, this is your real line, right? This is your real line. So I just want to demonstrate what we have. Real line, this is negative infinity, this is positive infinity. Then we know that 0 will be at the middle, right? So here, some here, we have 1 here, we have 2 here. So 2 is supposed to be located here. Then numbers bigger than numbers from 2 down to negative infinity, we have starting from here down here, right? Then negative 1, which this one we have it somewhere here. Here is negative 1. Correct. Here is supposed to be negative 1. So remember, the first thing we got is from 2 down to negative infinity. Just that's like this, right? Then the second one we got is from minus 1 to positive infinity. That's minus 1 to positive infinity. This one will go like this. It will go like this, right? So what is the intersection between the two? This place is the intersection. That's the intersection is numbers from minus 1 to what? Positive 2. So but we are looking for what? We are looking for non-negative integers. So we have many numbers that are in between 1 and we have many numbers that are in between 2 and minus 1. We have numerous of them, both some whole numbers and fractions. So if you start from minus 1, the whole numbers, the integers, which we call whole numbers, the integers we have there is minus 1. Then the next integer is what? 0. Then the next integer you are going to get before 2 is 1. Then finally you arrive at 2. So these are the integers starting from minus 1 to 2. These are the possible integers you are going to get. That's possible whole numbers you are going to get. We are now looking for non-negative, the one that are non-negative. So the only one that is negative here is what? Minus 1. So if you remove minus 1, we are having 0, 1, 2. So this makes this will make option A the correct option. We have 0, 1, 2. Okay, we solve this formally, right? But this is objective question. So for objective question, you are expected to arrive at the answer at the shortest time. The question says the non-negative integers that will satisfy this inequality, absolute value of 2n minus 1 less than or equal to 3. So n is n you are looking for. You are looking for n, and those n must be non-negative what? Integers. Okay. Now if you look at option A, there is no negative integer there. There is no negative whole number you can see in option A. Option B has one negative integer, which is what? Minus 1. This makes option B a wrong option, right? Because it contains a negative integer and you are looking for non-negative integer. Option C does not have any negative integer. Then option D has a negative integer -1. So option D cannot be the correct option. So you are left with option A and option what? C to consider. Okay. Now you are going to use you are going to do some analysis here. You are going to substitute this point and show that this inequality is what? Satisfied. Okay, coming to option A, for instance, if I substitute n for 0, you are going to have what? If I substitute n for 0, you are going to have 2 times 0 minus 1, because we have 2n minus 1, right? In absolute value. 2 times 0 is what? 2 times 0 is 0. So remaining minus 1, have absolute value of minus 1, which is what? 1. Because absolute value will always return a positive quantity. So absolute value of minus 1 is what? 1. Isn't it? Then, and clearly 1 is less than what? 1 is less than what? 3. So 0 should be one of those that non-negative integer. Okay, let's look at 1. If I put 1 for n here, I'm going to have absolute value of 2 times 1 minus 1 in absolute value. 2 times 1 is what? 2 times 1 is 2 minus 1, which is absolute value of 1. Because 2 minus 1 is what? 1. Absolute value of 1 is equals to what? 1. Of course, 1 is clearly less than 3, isn't it? 1 should be among the non-negative integer you are going to consider. Okay, let's check 2. Put n for 2 here. You are going to have absolute value of 2 times 2 minus 1. You are going to have absolute value of 2 times 2 minus 1 if you put n for 2 here. So this will be equal to 2 times 2 is 4 minus 1 in absolute value. This is absolute value of 3, because 4 minus 1 is 3. And you are going to, this is equal to what? 3. Isn't it? Because absolute value of 3 is 3. 3 is of course equal to 3. Because here you are having less than or equal to. So this quantity inside the absolute value, so the absolute value of this quantity should be a number that is either equal to 3 or smaller than 3, because we are having less than or equal to 3. So since we got 3, so 3 is equal to 3, so which means it satisfies this inequality. Then, so we are sure that option A is the correct option. Now, what of option C? What made option C a wrong option? Okay, look at option C. What I have here is 1, I have 2, I have what? 3 as the non-negative integers. We have already substituted 1 when we were checking option A, and we have already substituted 2 when we were checking option A. The only different integer we have here is what? 3. Now, if you put n for 3 here, you are going to have absolute value of 2 times 3 minus 1. All in absolute value. This will be 2 times 3 is 6, and we are having minus 1. And 6 minus 1 is 5. And absolute value of 5 is 5. 5 now, the question is 5 smaller than 3? No, 5 is not smaller than 3. So which makes option C the wrong option, because the result supposed to get should be either equal to 3 or smaller than 3, because we have less than or equal to 3. So but the result we got there is 5. 5 is bigger than 3. So which makes the option C the wrong option. So the only correct option is option A. This is how you can do it for objective setting.